Moving on to binary fluid, a fluid that consists of two types of chemical species and phase behavior that is much more complicated than pure fluid. Let's look at the PET-XY diagram. We'll use an example of methane and ethane and focus on liquid-vapor-liquid equilibrium. Methane is more volatile component which is labeled as component A, while ethane is labeled as component B. As you can see on this diagram, the key feature of this phase diagram is the solid body in the center of the figure. Within the solid body, the system exists in a two-phase mixture with a coexistence of liquid and vapor phase. Above the body, the system exists as a single liquid phase. Below the body, the system is a single vapor phase. The upper surface marked as red point that bounds the body is the locus of bubble point. And while the point that labeled in green is the lower surface at which the point at which droplets begin to appear in vapor, it is called the locus of dew point. Moving on to the vapor-liquid equilibrium is the state of coexistence of liquid-vapor phase where Y is referred as the vapor and X is a subscript to refer liquid. This composition surface which contain the equilibrium state of saturated vapor and saturated liquid for a binary system. The undersurface contains the saturated vapor state. It is the PTYL surface where the subcooled liquid region lies above the upper surfaces. While the upper surface contains the saturated liquid state, it is the PTXL surface. The superheated vapor region lies below the undersurface. While the interior space between these two surfaces is the region of coexistence of both liquid and vapor space. The critical locus is defined by the point at which the vapor and liquid phase in equilibrium becomes identical. And hence, due to its complexity, we will actually look at this phase transition in a 2D graph, which is by looking at the PXY diagram as well as referring to this TXY diagram. That's all.